Welcome back. In the last session, we talked about ensembles of ensembles, model stacking. We looked at different types of classifiers ensembling, and we also now, in this session, we're going to look at ensemble with a single type of classifier. So specifically, we are going to focus on this one here. Now, before we move on, there's just something that we want to look at, which is really specifically on the area of the data itself. So I'm going to do this, copy this, and go all the way to the end here. Now, we go at single classifier. Okay. Pandas. Okay, so we need to run the whole. Okay, restart and run all. Okay, that will just take a couple of seconds. And close that off. Okay, that's run now. So let's have a look at df. And you look at the yes df, and we're going to look at the attrition. We did this exercise slightly earlier, and we're going to look at the value counts. All right, notice how unbalanced the actual data is. So what we will do is we need this total counts. Total count. Okay, so we have 83 to 16%. So we're going to need that a bit later. Now, having prepped that, what we're going to do now is that we're going to start importing. Let me think. Do we want to use random forest? I think what we'll do is that we use random forest. Okay, so looking at what we've done earlier, we have looked at decision tree, we have looked at random forest. So instead of using decision tree again, we're going to just do random forest. Ensemble, import random forest classifier. Okay, now I'm sure you still remember what we did earlier in previous session on the bagging. We're going to make use of that again. Bagging classifier. And we're also going to do one more, which is add boost. Okay, from sklearn ensemble, we're going to import add boost. Okay, add boost classifier. Okay, having done all that, the one thing that we do need to look at the actual class in the random forest classifier. So let's look this up. It does allow class weight to be specified. So we're going to make use of that, and we're going to call the class weight. And how you specify is that there are two classes. We have the class 0, and then we have the class 1. Okay, we have the class 0 being 0.84, and then we have the class 1 is 0.16. Just to make sure that we have done this the right way. All along, we've done the earlier split here, the actual data preparation. So our data will be X train, Y train. We're going to look at the DF, the Y. I think Y, yes, Y will be the right one. So there will be a bit of leakage, but we'll just use Y train. Okay, so let's make sure we know what type of data. Okay, Y train is a NumPy, so let's just change it to a pandas series so that we can do what we did earlier. Data must be one-dimensional. Oh yeah, we did this before, just change it to a list. PD series. Okay. Okay, so having done that, we just want to do this whole exercise. So just value count and divided by this whole thing, and then we just call this count. Okay, so so 0 is 0. Let's make it 0.83. This is 0.166, 0.834. Okay, so we've done that so that we're forcing our model to actually take into account of the unbalanced class weight. All right, so now we're just going to train our classifier. Okay, so we have our classifier which is using random forest. Maybe I don't call it, we'll just call it forest. And we call this, I'm just going to instantiate our random forest, and then we have our class weight. Is equal to class weight. Okay, so done. The next thing now is that we're gonna have adder boost. Now the reason we're gonna use adder boost is that, remember, adder boost can work with multiple models. We did this with random forest before, so we're gonna repeat that again. And this time we're just gonna call it adder. It's gonna add the boost, and our base estimator, and it's gonna be forest. Okay, so that's our random forest. Okay, adder boost is actually boosting the random forest in this case. So the number estimators, we're gonna keep that to, let's just say, let's go 1000, and the learning rate, and just make it halfway for now. Okay, and the random state to 42. All right, now we just need to fit our model X train and Y train. Okay, let's do that. All right, while that is running, we've done what we needed to do, okay, at the basic level. Now it's just come over here and copy and paste this. Now, not forgetting that we need to change the classifier. The adder is actually taking a while. Okay, let that run. Okay, now that's finished running. In terms of in sample, it's done perfectly. So let's look at the cross validation score. That might take a while to run. And the next step after having done this is, remember, this is an ensemble of ensembles, okay, and essentially we are looking at this portion here. We're basically doing a bootstrap sampling right now using adder boost, and the underlying model that we use is random forest, which we have already fitted, and we have adder boost on top of it. And the one more step that we're going to do is actually do a bagging on top of that. So let's wait for this to run. Feel free to fast forward this portion. All right, welcome back. It's taken a while to run, so I decided to just cut that off. What last time on your screen you should have seen the 919 and also 283 correctly classified. Since then, the actual average accuracy has come through and the standard deviation has come through. The accuracy score is 86.14. So comparing this to what we had earlier, 75%. So it's an improvement. All right, so that's a good thing. So let's see. The random forest by itself was 8558. All right, 8558. So let's come down here. 8558. So this is an improvement, ever so slightly, but still it's going the right way, and we still actually right now. What I've done is actually I've since typed in this bagging classifier, which takes the input of the adder boost. Now, just refresh your memory. We actually had a forest, okay, and the forest random forest classifier is actually the base estimator for the adder boost, which actually built on top of it. And now we actually have a bagging on top of the edible. And I provided a few features: input 50 estimated, maximum sample, and also maximum features. Both one, bootstrapping is true. We're not bootstrapping the feature this time around. We're gonna make use of the full all the cores on this computer, and we fit it. And now we're running the actual performance parameters now. Again, I'm gonna pause this video. When this finished running, I'm gonna come back and explain this part to you again. Welcome back. That finally finished running. It took probably about half an hour. Now that's because I went back and I stopped the whole notebook and I changed the edibles estimated to 100 instead of 1,000. It would have run for at least a couple of hours if I had left it that way. I didn't want to wait that long, sorry. I just wanted to actually just have this generated, because at the end of the day it's really about illustrating to you the actual process itself. And the actual tuning itself is the next step. Well, unfortunately, the recall was pretty poor. The precision was really high, but the recall was really quite bad, and F1 wasn't any better either. So if we look at the overall accuracy, which is actually very misleading in this case, because we have an unbalanced class, it's actually better to look at the classification report. And if you look at the confusion matrix, notice that that's 58 was actually classified wrongly. So that's really the end of what I wanted to cover in terms of the single classifier ensemble with a single type of classifier. Basically bootstrap was done, and then with one single model, and after that is combined to create an ensemble, and after that we actually did another layer on top of that, which is bagging itself. I hope that has been really informative, and one that actually has helped you to understand how the process actually flows. This pretty much ends the segment of ensemble learning, the complete ensemble learning. We cover many things, and I thank you for watching right through, sitting patiently and listening through all of the presentation that I did. Okay, so with that, I'm going to end this video, and I look forward to speaking to you in the next section. Thank you.